In the European Union and the United Kingdom, 75% of all 117 million buildings are energy inefficient. This means that more than 385 million people cannot heat efficiently. This is a burden on the environment and the wallet. Today I will be presenting you a solution to this problem. My name is Niels Lindberg. Welcome to our technology studio. Together we'll take a look at the gas absorption heat pump, a heating technology that is the ideal solution for renovations, in combination with unlimited comfort. The cause for the inefficiency is the high energy demand of the building. This is caused by temperature losses at walls, windows and roofs, as you can see here in the thermal image. To reduce such losses, insulation of these places can be done, but this is usually complex and expensive. Now the question arises, what is the possibility for a faster renovation that sustainably reduces energy consumption? Let's take a closer look at the initial situation. In most buildings we find radiators, which often require high heating water temperatures of 60 to 70 degrees. New heating systems, such as heat pumps, reach their technical limits in these applications. Gas and oil heating systems can provide this heat demand flexibly. They quickly deliver temperatures up to 70 degrees, completely independent of the outside temperature. This sounds wonderful, but it still cannot be the solution to the problem, as fossil fuels are harmful to the environment. Electrical heat pumps convert free ambient heat into heating energy. Depending on where the power comes from, little to no fossil energy is needed in the process. So the question is, how can we combine the comfort of gas heating with the efficiency and sustainability of electrical heat pumps? But also heat pumps have their weaknesses. The lower the outside temperature, the higher the heating demand, obviously. However, at low outdoor temperatures, the heating performance of an electric heat pump drops significantly. To compensate for this deficit, additional electric heating is needed. This is inefficient and expensive. When an electrical heat pump is used in an uninsulated building, two basic difficulties often arise. First, the heating electricity tariffs common with heat pumps lead to energy suppliers cutting off the power supply for up to 6 hours, causing the house to cool down. Second, radiators require more water to be pumped through the pipes due to the characteristics of conventional heat pumps. The faster flow often leads to permanent flow noise. The solution is a symbiosis of a gas boiler and a heat pump. The gas absorption heat pump, an ideal solution for renovations. Ecology, economy and efficiency combined in one technology. Come with me. We'll take a look together at how this heating technology works in the lab. In this 3D model, you can see the first component of the gas absorption heat pump, the evaporator. In here, the temperature is below the freezing point. Quite cold. Now you're probably wondering, how can something evaporate at such low temperatures? There is usable heat energy in our environment even at sub-zero temperatures. The transfer takes place through the initially liquid refrigerant, which absorbs the heat from the environment and becomes gaseous. See for yourself. Here you can see how the refrigerant in the test tube evaporates already at -30 degrees. Although it is this cold here, at this point the energy of the environment is transferred to the refrigerant. And already we have gained 30% of the energy we need for our heating circuit from the environment for free. Let's have another look at our model of the gas absorption heat pump. In a second step, our gaseous refrigerant enters the absorber. Inside there's water. Water absorbs the refrigerant. This means it mixes. In our case, water combines with the gaseous refrigerant and reacts. During this process, energy is released. A look at the thermal imaging camera shows how the temperature rises. In the heat pump model, we see how a pump transfers this mixture to the generator. In the generator, a gas burner is now heating up the mixture. This adds more heat energy to reach the temperature needed for the heating system. This causes the substances to separate again. The water remains liquid, but the refrigerant becomes gaseous. The separated water is then returned to the absorber. In the condenser, the gaseous refrigerant releases its energy to the system in the form of heat. In the process, the refrigerant liquefies again and is returned to the beginning of the cycle. In our glass spiral, we see the gaseous refrigerant flowing into the upper third. It then cools down in the middle section. Drops form, which finally collect again as refrigerant liquid, and thus the cycle closes. Let's have a look at the interaction of all the individual steps. In our 3D model, you can now see all functions of the absorption circuit. This technology is absolutely reliable, wear-free, and with an efficiency of over 130%. Highly efficient. So, what does the gas absorption heat pump technology bring us? Easy, energetic modernization of 85 million existing buildings across Europe. High flexibility for any heating situation and thus maximum comfort. The use of 30% renewable energy, saving us money and protecting the environment. A lot more information on the advantages of gas absorption technology, such as minimal noise, sustainability, and comparisons with other technologies, can be found on our website, theheatingsolution.com. I have presented you an innovative technology which is an ideal heating system for renovations.